Hello, LatinDisplay. This is Chris Chinnock speaking. I am the president of Insight Media and also the executive director of the 8K Association. And I'm coming to you today from Connecticut in America, near New York. And that is not the weather we have right now. I hope to see that weather in a few months, but until then, we'll have to endure through a little bit more of winter. So I'm going to talk to you today about 8K. So let me share my screen and begin my talk. Okay. So we'll start with a little bit of an introduction on 8K and then talk about the whole ecosystem from content creation, distribution, playback, display, and then a little bit about the 8K Association. So I think most of you probably know what 8K is. It's a lot more pixels, and I like this this image here because it kind of shows you the scale of going from HD to 4K to 8K. If you keep the pixel density the same, that's how big a bigger canvas 8K is than HD or 4K. It is quite enormous change, and that's why people are excited about it, of course. So 8K is just the latest in this trend of ever increasing resolutions. We've gone through several of these transitions already, from standard definition to high definition, then to 4K, and now we're in the process of moving to 8K. But it's important to remember that 8K is not just about more pixels. We're going to high dynamic range pixels with 8K for the most part. So it's wider color gamuts, it's HDR, so you're getting a really impressive image. 8K is, for the most part, the state-of-the-art best capture system, although there are even higher resolution cameras out there right now. I'll tell you about in a little bit. But if this is done very well, captured and processed and displayed correctly, it is a kind of a wow moment for many people when they see that 8K image. Much like many of you probably went wow when you saw that first 4K image or the first HDR images. So it is impressive when done correctly. So let's look at this kind of the history of these resolution transitions, and you can see from this chart here there's a pretty consistent pattern of 7 years, and the 7 years is measured from the introduction of a resolution to 50% of sales. So we've had 3 of these on a pretty consistent cycle. So will history repeat? Probably. Now it may be a little delayed due to COVID, but it's not probably that significant. That'd be my suggestion. So let's delve a little bit deeper into the content creation process. So what are the key benefits of capturing in 8K? Well, they're a little bit different for live and file-based, but there's a lot of overlap. So if you think about a sporting match, for example, in live, you can have a high camera that sits and looks at the entire sporting field, and that allows you to perhaps eliminate some other cameras because you have high zoom capabilities. And you also have this capability now to define regions of interest, which might be a player or a ball or some other object that you want to track. And these software-defined regions can actually move around within this 8K cameras, and those regions of interest can go directly out to broadcast. So that may be able to save you some extra camera positions, which could offset the cost of the 8K camera. So there's also this capability when you have 8K capture and you're going to be down resing that for a 4K or 2K deliverable if it's a file-based system, for example. That allows you to do something similar. It's called pan and scan within that. You can reframe and recrop, which gives a lot of flexibility for the filmmaker to get just the right image that they want on the screen. And it's also a well-known fact that if you capture at higher resolution and then process that to master it at a lower resolution, you get a better image, a higher fidelity image than if you captured at 4K and mastered at 4K, for example. And there's also an interesting side benefit here. A lot of commercial uses of video cameras will also have to have a digital still camera, a photographer on the set too. If you're doing a commercial, for example, you might use a video, but you'll also use a photographer to capture high resolution stills. If you now use an 8K camera, you can actually use the screen grabs from the 8K image. They're not good enough for photographic purposes, for advertising purposes or other higher resolution needs. So an interesting side effect. And if going back to the entertainment space, a lot of movies have special effects. If you have an 8K image to work with, it's much easier for the special effects people to do their job. They can see clearer edges, finer lines. They can do plates that are much cleaner and nicer. So it just creates easier and better special effects. And perhaps the most important reason, of course, for live or file-based is the future-proofing of this. The archiving is going to go out at a higher resolution master, especially if you finish this thing at 8K, but at least having original camera files at 8K is a better starting point for sure. So here's this this region of interest application I described. This happens to be a concert, of course, but it can be applied to sporting events as well. And there are multiple companies out there that actually have hardware and software that can do this already. So this is a very real and useful application for 8K cameras. So are there 8K cameras out there? Yeah, there's actually lots of them. We've got cinema grade cameras from a number of vendors. Cinema grade cameras typically have larger sensors, so they have a shallower depth of field. That gives you that cinematic look, that bokeh effect that people like. Broadcast cameras have smaller sensors, so a deeper field of view to get that the whole sporting field or more of the sporting field in focus at one time. We're seeing consumer grade cameras coming out that are going to be in the $5,000 or lower range, high end for consumer, but certainly a prosumer level camera as well. And did you know that some high-end smartphones also have 8K cameras in them now as well? So I think between the smartphone cameras and some of these prosumer grade cameras, you're going to see a lot of user-generated content, and those become great ways to put up content on these 8K TVs. We saw that happen with 4K and with digital still cameras, so this is another way to kind of drive the market for TVs. But there's more. Here is a 12K camera from Blackmagic Design if you want to go beyond the capture. So think about this. You want to master and finish in 8K? Well, capture it in 12K and you get that better 8K image than if you captured it in 8K natively. So the cycle keeps going on here. And that's not even that expensive for a 12K camera. And if you want to go even further to 18K, there's a camera out there for you too in a 4:3 aspect ratio. So more appropriate now for IMAX capture and a little bit more pricey at $200,000. So where are we in terms of 8K production? Well, as you know, I'm sure that the 2020 Summer Olympics in Japan were supposed to be captured in 8K and broadcast in 8K by NHK. That is obviously, hopefully going to happen this summer. And that we'll also see other major sporting events like the 2022 Beijing Olympics and 2024 Paris Olympics are likely to be 8K. I wouldn't be surprised if the 2022 World Cup was also featured in 8K as well. We've seen multiple companies doing some trials and demos of other sporting matches in 8K. Those have pretty much been on hold for the last year, but I suspect those will start to ramp up again once we can get more activity in real sporting events. And did you know that many movies and TV shows are actually captured in 8K today for a number of the benefits that I enumerated earlier? Very few are mastered in 8K and distributed in 8K. But nonetheless, the content creators recognize the benefits of this oversampling And so the archive of 8K camera files is out there, which will be very beneficial when the business models for mastering and distributing 8K become more mature. So production equipment. Production equipment is clearly here today for both live and file-based. For the live applications, NHK has led the charge for almost 20 years now. They work with a lot of Japanese equipment providers to develop the hardware and the software to be able to do this. So all that equipment is out there. NHK has been broadcasting on air for over 2 years now. So that ecosystem is there, it's mature. We're starting to see other vendors expand their product lines to add 8K equipment. So it's definitely there. From the broadcast, well, from both broadcast and file-based, there are some pain points out there, and there's plenty of fear, frankly, that for adopting 8K. And a lot of that revolves around the added processing power that you're going to need to do this, the more memory and storage that will be required, transport bandwidth if you're moving this kind of files around production environment. That's a lot of data you have to move around. Do you have the infrastructure for that? But the good news, I think, is that these were the similar pain points that people had 6-7 years ago as 4K came on board, and we're certainly seeing 4K has been being very rapidly adopted in the file-based and TV and production space. Not so much in broadcast. It's a tougher nut to crack in broadcast, that's for sure. But I think it's a different environment now for broadcast. We're seeing, certainly with the pandemic, a major shift to move to remote production capabilities, all cloud enabled. We're seeing the advent of a lot of AI assisted processes and analysis that is helping this production workflow. We're seeing a trend for broadcast production plants to be re-engineered with IP infrastructure. We're seeing a trend for broadcasters to be able to distribute their linear channels over their traditional means, cable, satellite, to now also be able to do that over IP networks. So it's a different environment now, and I think this is both a technological environment and a business environment could be much more conducive for broadcasters, particularly to adopt 8K going forward with an IP-centric and cloud-centric business model. So let's talk about transport a little bit. If you're going to move files around in a production environment, you're going to need the 8K 60p as maximum, but 422 and 10 bits. So that's about 40 gigabits per second of uncompressed video. You can do that with 4 12G SDI cables, which have to be synchronized carefully, and that is being done by some. But you can also do this using the new SMPTE 2110 IP transport protocols. Now, those are going to need 4 Ethernet cables if you have a 10 gigabit network, or if you have a 40 gigabit network, you can do that with a single Ethernet connection. Not too many have 40 gigabits, but a lot have 10 gigabits at this point. So to the rescue comes new mezzanine codecs. JPEG XS, for example, has now been standardized and is starting to roll out in some facilities. That enables up to 15:1 compression in a lossless manner. And that allows you now to use a single 12G cable or a single 10G network connection to move these professional 8K signals around. And if you need to do facility to facility kind of contribution signal transport, there are protocols out there to do that as well. Very high reliability transports with SRT, RIST, and other mechanisms. Actually, 2110 has a redundancy capability as well. So those capabilities are out there today. So I think to summarize, there are some clear benefits for 8K capture and remastering. The entire production ecosystem for live and file-based is available today. There is fear and there are some pain points for adopting this, but I think both the technical and the business environments are changing very rapidly. And part of what we want to do at the 8K Association is to educate, to try and talk about how these barriers are changing and reduce the fear for adopting 8K content. So let's move on to distribution a little bit. So distribution, in my mind, is now taking this mastered content and distributing it with very high compression ratios out to the end user. So today we have codecs like HEVC and AV1, as well as in development, new codecs like VVC, EVC, LC-EVC, and there's even a Chinese consortium called ABS3 that's developing similar codecs for their market as well. This is a very unusual time in the codec space. Historically, codecs have been developed and rolled out to the industry on about a 10-year cycle. Now we're seeing all these codecs in the market pretty much almost simultaneously. Certainly some of these are coming a little bit later, but they will all be in the market at the same time. Many have different attributes to them, of course, and will fit different use cases, and we'll probably see most of these adopted in different use cases. That's kind of unusual. It's also pretty challenging now for the whole ecosystem to be able to absorb all these codecs. It was a much easier world when there was one dominant codec. So that's a bit of a challenge, but also an opportunity. So 8K distribution is a bandwidth hog. There's no doubt about it. NHK is using HEVC today over a satellite transponder service, and they are doing this at 80 to 100 megabits per second. That's a big data rate and not really commercially viable except for NHK, which happens to be government supported. So we're going to have to find ways to bring that data rate down and down significantly if we want to see commercial deployments. So these codecs will definitely help. I think in the longer term, VVC, EVC, and ABS3 are probably your likely winners for 8K distribution. But we want to find some solutions in the short term. So those are going to be LC-EVC, HEVC, and AV1. But coming to the rescue here are going to be a whole bunch of smart and AI-assisted technologies. This is one of the things that's going to be different than previous transitions and will, I think, help accelerate the development of this whole distribution ecosystem. And I'll talk a little bit about more of this. So what is smart streaming? Smart streaming means different things to different people, depending on who you're talking about. From our perspective, from the perspective of the 8K Association, what we would like to see is first encourage people to master their content in 8K, then use a professional down conversion technology to scale that down to 4K resolution, but with smart metadata or some information to describe how that was down-resed. That can now be encoded with conventional codecs, AV1 or HEVC, streamed as 4K with this extra metadata. And now this metadata can be used by smart 8K TVs to restore that 8K image. If it's 4K TV, it just ignores that metadata. So this kind of capability has already been demonstrated by a number of companies like Samsung, Sharp, Fujitsu, and Harmonic, but they all use different methods and proprietary signaling and encoding. So our challenge from the 8K Association and the industry perspective is to see if we might be able to find a way to standardize this process to allow multiple ways to do it, but standardize the signaling and the input and output parameters and structures. So that's one of the things we'll be looking at. But there are lots of other things that are going on in the smart streaming space, because this is just one aspect of using AI or machine learning. Um, you can use content-aware encoding that looks at the type of content and adjust the encoder based on the nature or the genre of that content. There's adaptive encoding. There's other kinds of AI-assisted encoding that look at, how you construct the streaming ladders. There's lots of stuff going on in this space, and we're just starting to investigate. That's what's really cool about this. We're just at the very beginning of all these AI-assisted machine learning and neural network kinds of solutions. But there's a lot of different dispersive efforts going on here. So we need to try and communicate with these stakeholders and try and see if we can help standardize some of this if whatever we can, and or work with the standards development organizations to help move this ball forward. Internet delivery, we believe, is going to be probably the leading way to get content to the home for 8K, just as it has been for 4K. Dash and HLS are the main streaming protocols that are out there today. Historically, those have been incompatible formats and had long latency. To the rescue recently has come CMAF, which creates smaller chunks and to reduce that latency, and provides a way to combine these into one media file, one MP4 container. So that's available today, and that's not just for 8K, of course. That's for any resolution content, and we're starting to see that rolled out right now. But that will certainly help with 8K content as well. Satellite and OTA, over-the-air delivery. As I mentioned before, NHK is using satellites to deliver that today. They're also starting to look at over-the-air options. But frankly, I'm not very optimistic about satellite delivery for 8K. Worldwide, we're seeing a decline in using satellite distribution for television services. That's because those satellites were put up many years ago and don't really have the capacity to move into 8K. You can do it with 8K, but it takes an entire transponder capacity, which is not economically very viable. Even with some of the higher, newer codecs, I think these will be challenged. DirecTV, for example, here in the U.S. is not going to be launching any more satellites, so they're moving completely to an IP infrastructure at this point. In terms of over-the-air, we have ATSC 3.0 and DVB-S2X, and those don't currently have definitions for 8K right now, but there are companies that are working on that. For example, in Korea, this organization ETRI has shown that you can broadcast 8K over an ATSC 3.0 system. It does require some changing in the way that they modulate the signal and the equipment changes, so it's possible, but it's going to take some effort if people really want to have that option. So I think IP still remains the more interesting option for 8K, I think. People also talk a lot about 8K and 5G. But 5G is not just as uniform as, well, even 4G wasn't that uniform, but 5G is even perhaps more diverse with three major bands here: a low, a sub-6, and a millimeter wave bands. And they have different characteristics. Of course, the higher frequency you go up, you end up being line of sight actually with millimeter wave. Short distances, no ability to penetrate walls, but very high data rates. So you can and the various carriers are rolling out 5G services with mostly low band and sub-6 services to consumers right now. And the problem is most of the hype and discussion about the benefits of 5G are talking about millimeter wave applications, not these lower band applications. There a lot of these benefits, like efficiency, go to the carrier. Latency is one that goes to the consumer for sure with these lower band solutions, but and they will have some more data rates, but it's not as big as the hype suggests, I think. So the reality is 5G, millimeter wave 5G will be used in backhaul, private campuses, commercial applications. So between buildings is great. It may be in higher metropolitan areas. You can go from building to building and block to block. But once you get into a building, you're not going to have 5G transmitters down every hallway and area, and once you get into your apartment or to your house, it's not big. You're not going to have a 5G millimeter wave transmitter in there either. So it's going to go down to something lower. It could be a Wi-Fi connection. It might be, realistically, most of them are going to be, the sub-6 applications or the low band applications that you're getting 5G on. These may be all right, but I think you're going to have to be very careful with expectations for 5G is my suggestion. I think cable distribution is going to be much more likely for broadband. Here in the U.S. and I think of other parts of the world, we're going through a major backbone upgrade right now to 10G, 10 gigabit per second fiber networks. And this will be about a 10x improvement over the current systems that are out there right now, with better reliability, better security, and lower latency. So as with any cable network, the actual service that you get in your home will depend on number of people, a number of homes that are on the node, number of people are on at any time, the mixture of copper and fiber. So your experience will clearly vary. But I think the good thing is the cable industry is also working very heavily to also roll out Wi-Fi 6 as part of this infrastructure, so it can move very seamlessly now to a Wi-Fi solution once it leaves your cable set-top box, for example. So speaking about local activities in the Brazil market, I reached out to Globo about their 8K plans, and they have worked out a deal with NHK to get some of that 8K broadcast content from the Olympics, assuming they take place this summer. And specifically, they want to use this content to understand some issues with a potential streaming service that they might put together in Brazil. They want to understand what's the best approach to do this, what are the best bit rates, well, how do you construct ladders correctly, how do you leverage the video up converters that are in 8K TVs today, and this kind of comes back to that smart streaming discussion that we had a little bit earlier. They also need to understand how you're going to do 8K productions, potentially even remotely. What's the best mezzanine codecs? What are the best transport solutions? How do you manage all these multiple camera formats in a production? Remember, not every production is going to have 10 or 20 8K cameras. You'll have a couple of 8K cameras, and you're going to have 2K and 4K cameras out there with a mix of SDR, HDR, frame rates, resolutions, and codecs on all those. So, what's the best way to manage all that? The 8K Association wants to help understand that as well, and we will be putting together white papers on this, case studies, workflow diagrams to help educate about what other people are doing to help move this forward. So in summary, smart streaming, I think, will be a significant way to reduce the data rates down to more manageable and commercially viable data rates. If we can make that happen, it's still a bit of a challenge. I think the technologies are there, but it's more of an IP and a business model and a standardization challenge right now. We have codecs that are ready to go today to distribute 8K, but we need to do a little bit more AI-assisted work to get those data rates down. But I think that's going to come fairly rapidly. And to the rescue come new codecs like VVC, which will help as well. And all of these things can be combined to really start to drive innovation in this whole encoding and distribution workspace. I think satellite and over-the-air are going to be challenging for 8K in the near term for sure. 5G may be a little bit overhyped for 8K, certainly to consumer homes. And cable networks, I think, are best positioned at this point. Cable and Wi-Fi are best positioned, I think, to deliver 8K to homes at this point. Will we see some streaming services? There are a few little things that are out there right now. You can stream things from YouTube and Vimeo for sure. The Explorers has an 8K app that sits on a Samsung TV for their 8K content. But I think we're going to need the bigger players to get in to really make this a market. And that's probably a couple of years off, although maybe a little bit sooner, because I'm certainly starting to hear some more talk about from some of these streamers that are getting more interested in 8K now. So this is probably about the right time for them to start to get interested. Let's move on to 8K playback. So I think a new 8K Blu-ray disc format is unlikely. Certainly fixed media is in decline. It had a bit of a revival this last year because of the pandemic, but the clear trend is towards streaming at this point. You could see things like USB sticks that are perhaps pre-programmed with 8K content that you plug into the back of your TV. Think of it as a red box service, if you will. I go to your convenience store and pick up a USB stick with an 8K movie on it. Why not? We're seeing there are no set-top boxes other than the one from NHK, and no streaming sticks out there right now that support 8K. But the good news is a lot of the chipsets, so the SoCs that support those kinds of devices have 8K capabilities today. So I think it's pretty much ready to go when the business models are there and the content is there and the critical mass of TVs are there for this to start to roll out. The first AVRs are in the market now. They have 8K pass-through and 8K upscaling. And you probably heard of the new consoles that are out there, the PS5 and the Xbox Series 10. These will support 8K playback. They do have HDMI 2.1 interfaces. They're not configured for 8K output right now, that's my understanding. But that will come through software updates sometime this year is my understanding. So in the distribution world, this is the number we want to look for. We want to be able to support 8K 60 10 bits, but with a 420 subsampling, which is 30 gigabits per second. So if you want to do uncompressed from whatever playback device you've got to your TV, you need to support 30 gigabits. So what wired connections can do that? Well, the ones in yellow are the ones. HDMI 2.1, DisplayPort 1.4a with DSC, a display stream compression only, or DisplayPort 2, Thunderbolt 4, and USB 4 in the DisplayPort 2 alt mode. So this is all good news. This means the wired connectors are there to support 8K 60 content as the content and the other devices in the house become available. I mentioned Wi-Fi earlier, so Wi-Fi 6 routers and devices are out there now. They do use these same 2.4 and 5 gigahertz bands, but this new protocol increases speed, and most importantly, it allows for bonding of channels. So if you want even more speed to support that higher data rate of 8K, you can bond 2 or 3 channels to get that. And reduce latency, of course, is always important. And the FCC here in the US has just authorized the use of the 6 gigahertz bands, which opens up a third band for Wi-Fi routing that will allow even more speed and capacity. So we don't see Wi-Fi as a problem right now for 8K streaming. Moving on to displays. So we know that there's not a lot of 8K native content out there. So the reality is there's going to be lower resolution content for quite a while. And so the best way to enjoy your new 8K TV is to have a robust upscaling technology. Well, the good news here is AI technology comes to the rescue here again. So this is very different than what the previous upscaling technologies were. So most of those in the past have been based on nearest neighbor scaling or kind of simple algorithms based on pixels that are nearby. So today, what we're using is machine learning and neural networks to process these images in much, much different ways. And all of the top tier 8K TV manufacturers have these kinds of capabilities on board today already. For example, the new Samsung TV line, 8K TV line, has even has increased this kind of neural network processing. So the way they do it is they have an initial neural network that looks at the incoming content. They look at the data rates, the resolution, the sharpness, a whole bunch of different characteristics to understand, what's the nature of this content that's coming in now? How good or how bad really is it? And based on that analysis, they send it now to one of 16 optimized separate neural networks that are designed to take care of exactly the problems that have just been identified in that first neural network. Now, I haven't seen the results of this yet because CES this year was all virtual, of course, and no one's really been able to see much of anything. But based on last year's technology that I've seen for upscaling, my personal opinion is that these algorithms are very good at upscaling 4K content. They do make it look better than 4K. They're good for 2K content, and they're okay for 720 or SD content. My expectation is with some of these newer algorithms that evaluation will move up a bit. So all good news. And even better, a lot of these neural networks in these TVs are upgradable over time. So, in the past, the upscaling was just fixed, but now you have it's a dynamic process. So this is a very important piece to make from the consumer perspective now. There's a really good reason to buy your 8K TV because they can make almost any content look really good. So TVs are certainly the main devices out in the market today. There is a monitor that's offered by Dell, Sharp, and others may enter this year or sometime soon. We're seeing 8K VR headsets with 4K per eye. We've heard rumors that Apple will offer one with 8K per eye. Digital signage is out there today with LED walls that are 8K and higher for sure. I mean, there are mega digital signage walls out there that need 8K content. Maybe you'll see an 8K screen in a laptop. I think you won't see it in phones. I think that's a little bit overkill, even for us. In terms of TV technology, we have LCD TVs that are available today from 55 to 120 inches, using a whole bunch of different backlight technology. Well, dual cell is not really a backlight technology, but it's two LCD panels joined together. I'll talk about that a little bit more in the next slide. MiniLED offers thousands of zones. Full array local dimming backlights offer hundreds of zones, and edge backlights equals dozens. So the point here is that you can get the kind of image quality at almost any level here. And the whole point of going to dual cell and mini LED is to get the kind of pixel level dimming and black levels that you can get with OLED, which is still top of the line in that area. So OLED 77 and 88 inch 8K TVs available today. Micro LED TVs are out there. They're very expensive. They're very large. But I think that technology will continue to improve going forward. Next year, we could very well see QD on OLED technologies, which is being developed by Samsung Display, I believe Sony and Samsung Electronics will be offering those TVs next year, and I'm sure there will be 8K versions of that as well. Electroluminescent OLED, maybe. So here's the dual cell. Again, the idea here is you put a monochrome panel in between the backlight and the front full color LCD cell, and you get much better modulation of that backlight illumination now. We've seen an 8K 4K prototype, so it's a 4K monochrome panel modulating an 8K color panel. It's unclear if that will become a product at this point. Hisense is the clear company leading the charge in dual cell. It's great because it offers a lot more dimming control to get great black levels, with really reduced haloing. The trade-off here, the downside, is that it's got lower efficiency, higher cost, and some viewing angle challenges. Mini LED. So these take the idea of in a full array local dimming, you've got kind of larger LED devices in the backlight. Now you shrink those from the dozens or hundreds to thousands and sometimes tens of thousands of mini LEDs, so much higher density distribution of light, obviously, in the backlight. And the emitters now shrink to on the order of 100 to 300 microns. So the development of mini LED technology was pretty much pioneered by TCL. They were the first to commercialize it, and they took the basically the idea of what's used in LED digital signage, putting LEDs on a PCB board with passive driving, and they made a backlight out of that and put it on a TV and commercialized that. And the second generation they showed last year at CES, it took the mini LEDs and put them on a glass TFT backplane, as you would for an LCD TV, and they made a backlight out of that. The third generation, which was debuted this year, basically takes the PCB approach, but makes it a very thin display. So TCL showed that, Samsung showed that, and I think not only have those two companies now jumped in on this in a big way, but now LG Electronics has also jumped in on the mini LED bandwagon as too. And that was one of the bigger takeaways from the virtual CES this year. The benefit is definitely better black levels and reduced haloing. It does add some cost, but it's also, I think, a better option if you want higher brightness from your TV. If you watch your TV in a brighter environment, you may want the higher brightness that a mini LED LCD TV can offer, as opposed to an OLED TV, which does have a high end on its brightness level. Micro LED, it's clearly an emerging technology. You can make 8K video walls. There's no doubt about it. The wall is an example of that. CLED from Sony is an example of that. They're very expensive. And actually, Samsung has announced that they're going to have a 110-inch that will go on sale this spring. I think it was about $150,000, and you've got 90-inch versions coming as well, and maybe another size or two as well. So it's starting to happen. Still expensive, but we'll have to see how that's going to evolve. Lots of challenges with manufacturing here. I'm not going to go into all those details. So in summary, 8K TVs are coming from all the major brands. Now that you'll see a different availability, of course, and depending on region. And the prices are definitely higher than 4K TVs, but that's not unusual for the introduction of a new technology in the TV market. I think the good news here is over the last few years, we've seen a major investment in 10.5G fabs, especially in China. These are optimized to produce 65 and 75-inch displays. So I think this will be a major driver for bringing the prices down for these 8K TVs, as I expect many of those substrates will be devoted to 8K panels. We saw the same phenomenon with 4K TVs and 8.5G fabs. There are a lot of those that were developed, optimized for 55-inch displays, and guess how the price of 55-inch 4K TVs came down rapidly. Wide adoption drove that seven-year adoption cycle. So I think history will repeat here to a large degree. And we've got new technologies that will help invigorate this market, of course. So let me switch gears a little bit and tell you about the 8K Association and how we're trying to help. So one of our clear mission goals is to educate both consumers and professionals about 8K. And we want to encourage the expansion of this whole K ecosystem by educating professionals primarily to try and lower their fear for adopting 8K, to help move standards along, to help remove some of the barriers, the technical barriers and the commercial barriers, the business barriers, to enable 8K streaming services, or however they're going to distribute it to consumers. On the consumer side, we also want to help them in making buying decisions. So we have a certification program to help do that. We want to embrace all uses of 8K and push for advancements in all these areas. And finally, we want to secure content for our members. Our members want to be able to test content. They want to be able to show this in trade shows and private demos. We want to potentially be able to offer 8K content to other organizations as well, in particular standards development organizations, so they can develop the tools to evaluate 8K content. So we have these two websites, the professional-facing one and the consumer-facing one. In terms of organization, a bunch of work groups: technology, content and distribution, marketing, legal, and certification. I'll give you a little bit about a few of these work groups next. In terms of members, we have 30-something members right now, and actually you can see kind of nicely distributed between TV brands, panel makers, content creators, technology and equipment providers, test labs, chipset providers, and streaming service providers, and we continue to add more members, thankfully. In terms of the marketing work group, so we will be kind of ramping up some of our promotion activities this year, in particular to talk more about some of the education that we're doing both in the professional side, but also on the consumer side as well. Particularly, we'll do some more social media and marketing campaigns, both on B2B and B2C. We're going to be doing a refresh of the 8K Association website, which will have an 8K capture and master and distribution theme focus. So we'll also be developing lots of deeper dive content for that website, case studies, white papers, interviews, workflow diagrams. Thank you. We'll also have an initiative on YouTube as well to develop playlists for 8K content and information, seminars, tutorials for professionals. If the Olympics are held this year, we're going to do a media event out there, and we'll continue to do all these seminars and webinars that we have been doing. We've got a lot of stuff planned in the content and distribution work group this year. So we mentioned this website redo and the 8K YouTube channel stuff. We're also thinking about doing a comparison study that looks at 4K and 8K images side by side. So there have been several studies that have been done on this with kind of different results, and our kind of takeaway from this is that that the way the content is captured, prepared, and displayed obviously makes a big difference. And also there's a big difference between the type of content or the genre of content. So content that has a lot of high resolution textures and edges and contrast will be more noticeable to the average person with an 8K version versus a 4K version. Some content won't. Some content that's captured in 8K but uses a legacy lens or a softer lens may lose the benefits of all that 8K capture right from the beginning. So you have to be very careful in how you look at this whole production chain if you're going to show images to consumers to ask them to compare 4K and 8K. So that's something we'll be thinking about carefully if we want to try and put something together to have a little bit more definitive understanding of the value proposition of 8K. As you heard from my previous comments, there's a lot going on in the codec space. There's a lot going on with AI in that area. So we're going to be working with a lot of stakeholders in this area to try and understand how we can help, how we can move this ball forward. So keep your eye out for that. In terms of content development, we have kind of two areas that we're working on here. One is we have actually three areas. We have a membership class that allows people to basically contribute 8K content to the organization in exchange for a membership, so members can use that 8K content. Two, we have an independent filmmaker campaign that we're doing. And here the idea is to reach out to independent filmmakers who have or are or want to embrace 8K. And we want to work with this group because they're more innovative and freer to innovate than some of the major studios. They typically don't have a lot of special effects, which can be a disincentive for some of the major studios to move to 8K finishing. And so we'll work with them to help finish their films, to help with their workflows. We'll promote what they're doing. We'll interview what they're doing. We'll help them get exposure for their content. So we've already helped one company, for example, finish their trailer in 8K, and that has helped them get a distribution contract. So we're happy to do things like that. There's also a new effort that's being led in Hollywood by ASC, the American Society of Cinematographers. And this is a refresh of a project that was done about 15 or something years ago as digital cinema was coming in. A bunch of cinematographers and content creators got together to produce some reference content that would be used to evaluate the new and emerging digital cinema projectors and other parts of the mastering production chain. That was shot on film. It was free to use as long as you signed a license agreement. But filmmaking has changed radically in that time. So this ASC group has developed a script. They've laid out a bunch of different challenging shots that they're going to do with this. And we will be involved with that. There will be an 8K master, of course, that's produced from this. And that will be more content that can be used by our members and potentially by other standards development organizations. Again, it will be reference content that's free to use with a license. So in general, we're trying to work with lots of players throughout this ecosystem to try and educate and move the ball forward. The technical work group I mentioned has developed this certification program. So they developed the spec. We've just released the version 2 of this spec, which adds some audio requirements to it and this new streaming media formats. And now we're starting the refresh of the technical spec, trying to figure out if we want to raise the bar and what areas we want to raise the bar in. So there could be a bunch of new things we will consider. New codec support, AI codecs, advanced AR, HDR capabilities, game mode requirements. Not quite sure yet. We're going to start to evaluate these things. So you'll hear about those in a year probably. And I will stop there. So great. Thank you very much for your kind participation and listening to me. I know I rambled on for a long time, so I apologize about that. So I will stop there. Thank you very much.